is a regression assignment from the university I work at, and it has two problems. And in this video, we're going to look at problem one, and then I'll make a video where we look at problem two. But you can see here from the instructions, let me get this first problem up in the window. Enter the data in a calculator and create a scatter plot. Then it wants you to choose the window settings, and it wants you to sketch that in there. So not copy and try and paste whatever was in your window. It actually wants you to sketch it. Draw it on that provided rectangle, showing tick marks or dots for scale and indicating your window settings. Determine an appropriate type of function to use to model the data, and calculate a regression equation and write it down. Rounding is indicated. Okay. And then use your equation from step 2 to answer the question in the problem. Now here's the main one that a lot of students will forget. Use a complete sentence. So if your answer is 5,023, you don't write 5023. You put it in a full sentence, like it was predicted that there would be 5,023 boxes on the assembly line. A full sentence. Okay. All right, so here's our problem, our first problem, Tennessee Farms, and we have our data there. Now, we are going to regard, so this is in a vertical table, we are going to regard these first entries as X values and the second entries as Y values. Okay, so I'm going to put them, the first column will be in list 1, and the second column will be my list 2 values. Okay. All right, so what I'm going to do is I'm going to come over here and I'm going to click stat, and then I'm going to click enter because my lists are empty. So list 1, I'm going to have 4, 9, 14, 19, and 24, and 28. And then I'm going to scroll back up and double check that I did not make a mistake. Okay. And my list 2 is going to be 93, 130, 179, 268, 467, and 856. And again, before I do anything else, I double check I have not made a mistake. Okay, now what about the window? Before I do anything else, let me just, okay, I'm looking at my X values, and you can see that the literal minimum is 4 and the literal maximum is 28. But what I think I'm going to do, I want things to be nice and good, nice numbers. Instead of taking it from 4 to 28, I'm going to take my X minimum to be 0 and my X maximum to be 30. Because I have to supply these grid marks here. And if I'm going to do that, it would seem I want the grid marks. I don't want to be, I do not want them to be really close together like that. We do not want that. And I don't want them to be spread too far apart. You know, something like that. So, first of all, I'm just going to take that from 0 to 30. And with my Y max, I want to take that, well, it goes from, my y values go from a minimum of 93 to 856. And again, I want my values to be nice. So I think I'm going to take it from 0 to 900. So I'm going to come over here and I'm going to look at these points in this window. But before I do that, it says create a scatter plot. Okay, so I'm going to get out of here. And I'm going to press second and then y equals. And then I'm going to press enter. And here where it's flashing, I want it on. I want my plot on because I want to see the points. So like I'll have a point with coordinates 4, 93, one with 9, 130, etc. Now type where it's already highlighted is scatterplot, so that's what I want. My x values, I stored them in list 1, so I don't need to tell it again. My y values, I stored them in list 2, so I don't need to tell it again. And then I'm just going to use the mark that's the default mark. Now what I'm going to do now is I'm going to click on Window. And I'm going to tell it what I've decided here. I'm going to take my x values to go from a minimum of 0 to a maximum of 30. Because it's the best way I can see these points, the best window. I'm going to skip over the x scale for now. And then I'm going to do my y min and y max, which I decided the nice numbers would be 0 to 900. And I'm just going to press graph now. So I'm not doing anything with the x scale and the y scale at the moment. Okay, so what I want, you can see grid marks here because every grid mark is a single unit, x unit. And the x values go from 0 to 30. That's too many grid marks. Okay, so if my x values go from 0 to 30, I think making my X scale a grid mark like every 5 units, that would be good. So I'm going to click here on Window, and I'm just going to come down to X scale, and I'm going to change that to a 5. Then I'm going to press Graph, and see, look at my grid marks now on the X-axis. That's really nice. I like that. So I'm going to go with that. I'm actually going to go with that. And so now I need to draw this. So like here's where 0 would be, and there's where 30 would be. And then the way I do this is like halfway between is where 15 would be. And so we can kind of see now 5, 10, 15, 20, 25, 30. I mean, it's not perfect, but it's really good. So it says to choose window settings to show all of the data points and to provide a useful indication of scale. Draw the scatter plot showing tick marks or dots. So I have shown these tick marks here. So 5, 10, 15, 20. I mean, I could have made that one a little bit better maybe if I'm really being picky. Excuse me. Okay, so that one's not so bad. And, you know, I don't need to write the numbers in, just so I have the grid marks. That's good enough. Okay. All right, now for the vertical scale, I'm going from 0 up to 900. So how am I going to make the vertical scale go? I think every grid mark should be 100 units. I think that would be better. So for my Y scale, let's see what happens. I'm going to press Window, and I'm going to come down here to the Y scale. So instead of every grid point being 1 unit, and those are so close together, it's just a solid bar, I'm going to make it 100 units. And then I'm going to press Graph. Okay, that is a lot better. Okay, I think I could do it that way. Maybe if I made, since 300's divided by 9, as is 150, I might could do. Let's see what happens if I change it to, say, 150. And then press graph. I'm just trying to get a nice spread, or if I get 300. So every unit now is, say, every grid mark is 300 units. Okay, that's not enough grid marks. I might go to 150. And then I'm going to press graph. Okay, that's looking pretty good. Now, how am I going to split that up? Well, with 900, you'd have like 3, 6, 9. Okay, if I divide it up into thirds, and I could probably make that just an eensy beensy bit better. Okay, and then halfway to 300 is 150. So I'm getting the grids now. And then 300 plus 150 is 450. And then 450 plus 6 plus 150 is 600. And 600 plus 150 is 750. That looks good. Okay. So I'm going to go with that. Now I'm going to draw these points. I'm going to plot them. So where would the point 4 comma 93 be? Well, there's 5, so 4 would be about here, and then 93 would be about there. There's the first point. Now, and see, we're just sketching. Now, what about the second point? 9 comma 130. Well, this is where 10 is from the grid mark. And so 9 would be about here, and 130 would be about there. Then 14 comma 179. Well, this grid mark is 15. So 14's about there, and 179 is going to be between 150 and 300. So it's going to be about there. Then 19 comma 268. There's 20, so 19 would be about there, and 268 is still going to be under 300. 24 comma 467. Well, here's 25. 24 would be about there. And 467. Well, here's 450. So 24 and 467 is going to be just above 450. And then 28 comma 356. So there's 30. 28 would be about there. And 856 is going to be really close up there. This is what I sketched just from reading this off and from the grid marks I made. And look how good it looks. Okay, so I did this by getting my grid marks, getting my min-max, getting my grid marks on the scale, and then reading off the points and plotting them. And that's pretty darn good, I think. I think that's pretty darn good. I'm going to take a little screenshot of that in the moment. Okay, so I don't lose it. Okay, so let me just... Now, because I have to... Now it wants the regression equation. Okay. So what I'm going to do to get the regression equation is... I'm going to get out of this screen, second mode. I'm going to press Stat. I'm going to go over to Calc. Oh, sorry, I need to get back. Let me get back. Okay, now I'm going to make this really small so I can get it onto the screen. Because I need to decide what kind of regression do I use. Okay. So now what kind of regression am I going to use? Now what I'm doing in red is not part of the answer. Like what I have here in black is how you would be expected to draw in that box. What I'm doing with red is just some extra. It seems that this curve has this shape, And that is the shape of an exponential. The curve looks like an exponential. Okay, so exponentials go like so. So I think it looks like an exponential function, so I'm going to do exponential regression. So I'm going to click on Stat, I'm going to go over to Calc, and I'm going to scroll down until I get to exponential regression. There it is. I'm going to press Enter. Now, my X values were in list 1. My Y values have already been stored in list 2. And frequency list, we leave that blank. Now, I'm going to get a regression equation, and I can actually have the option to store it. So I'll go ahead and store it. I'm going to press vars. I'm going to scroll over to Y vars, and then press Enter. Enter again. Enter again. And then I'm going to click on Calculate, so enter again. Okay, now let me get rid of this and get back to here. Okay, so let's get back to the original question. Now, your calculator is telling you that the regression equation is y equals a times b to the power of x. And it says to take it to 4 decimal places. So the 10,000th place is 4 decimal places. Now there's a reason why I'm writing this in red, because this is not how you're going to write your final answer. Okay. So A is to 4 decimal places is 57.1997, and then times, that's a times, not an X. So I might write it just with a dot. I might write that with a dot. And then B is 1.0939 if I take that to 4 decimal places. Then all raised to the x power. Okay, now that is the regression equation that your calculator gives you. That is not the regression equation for this problem. For this problem, your x values are in the first list, but they're actually t values. And your y values, which we made the second list, is actually going to be a v. So the way it needs to be written is, instead of a y, we have a v. Okay, so, and then I'm going to write a multiplication, and instead of an x, we have a t. And v is actually a function of t. So this is not v times t, this is v evaluated at t. So the regression equation that you would be expected to write, my function is v. It's a function with respect to t. So v, about the value evaluated at the time, is equal to that. All right, so that's what the department's looking for. Okay. I've had students take a pen and literally copy that and write it in there. That will get 0 points. The department is very fussy about how they want you to write the answer, and I'm showing you in this video how you're expected to write that answer. Okay, that's what you're expected to write there. Then it says use the model to approximate the average value per acre of land in buildings on Tennessee farms in 1975. Now, 1975 is not our t-value because our t-values are the time in years since 1950. So 1975 is 25 years after 1950. So for the year 1975, your t-value is equal to 25. Okay. And I just erased the equation. Okay. This is what I don't like about the pen. Okay, so let me try and correct that. Okay, so there we are. Now, okay, I've got that. All right, so I'm going to keep that. And then there's my regression equation. And I'll take a screenshot of that as well. Yeah, I got to keep taking screenshots or I'll lose this with my Epic pen. And I'll come here and do that. Okay. And so for 1975, t is equal to 25. All right, so that's telling you that t is equal to 25. So the average value per acre of land at the year 1975 is going to be my formula V evaluated at 25. Now there's two ways you can do this. It says to use the model. Now you can take this formula that you had, round it to 4 places, and you can plug in t equals 25. And I can do that in my calculator. So I'm going to put 57.1997 times 1.0939 to the power of 25. And it says to round your answer to the nearest dollar. So that'd be $539. Now, I'm not finished yet. There's 2 ways that we could do that. The other way you could do it is to get your calculator just to evaluate V of 25 in the original equation. So let me show you how to do that because we stored that equation. So I am going to press vars. Then I'm going to go over to y vars. Then I'm going to press enter. And then I'm going to press enter again because this is where I stored the equation. So instead of a v, it's showing a y of 1. And I need to evaluate y of 1 at 25. So I'm going to type in parentheses, 25. And it's putting 25 into the original equation that was taken a lot more than 4 decimal places. Now, with that one, if I round it to the nearest dollar, you can see it's a 0.6 something. So this first one, when I just plugged 25 in, it was 539.3, yada, yada, yada. So if I rounded the first one to the nearest dollar, it was $539. This second one, if I round that to the nearest dollar, that 0.6 is going to make that 540. The department will accept either answer, but you must give your answer as a complete sentence. So the department answer in a full sentence, which is what they want. The average value per acre of land and buildings on Tennessee farms in the year 1975 was either 539 or 540, depending on how you calculated it. The department will accept either one. Choose one though. Okay, so if you wanted to calculate it by just plugging 25 into that and punching that into your calculator, you would get 539. Or if you wanted to put it into the original equation, get your calculator to do the whole thing, you get 540. So none of this should be on your answer sheet. What I've typed down there is what the department is looking as your final answer for that one. Okay, so, and write it out nice and neat. Okay. All right, so, also, if you click on graph now, because you've saved that, where is that formula? If I press y equal, there it is, the original formula. And if I just click on graph, there we can see how that exponential function fits nicely onto that data. But we're not drawing that as our answer. As our answer, we're just drawing it like that. Okay. All right, so now what you guys need to do is to take your regression assignment, question 1, and go through that. Now, your question 1 may or may not be exponential regression. It just happens in this example, problem 1 was exponential regression. Yours might be cubic, linear, quadratic, or exponential. It's up to you to decide by what the shape of the plotted points looks like. Okay, so I'm going to stop this video now.